going to teach you about the nephron. So first, we're going to start by being a chunk of blood, right? We're going to flow into the kidneys. The nephron, as I have drawn here, is found in the uppermost part of the kidneys. And there are hundreds and hundreds of nephrons. And what they are is they are our filtering system of the kidneys. So we're blood, and we're going to enter the kidney nephron via the afferent arteriole. And then once we are in here, we're going to go through the afferent, and we're going to end up in the Bowman's capsule, but before that, we're going to be in the glomerulus. The glomerulus is this funky drawing here of a bunch of different capillary beds. And as you know, in the capillaries, that's where things exchange. For instance, in our lungs, that's where gas and oxygen exchange. So we're in the glomerulus, and this is the filtering system. This is where blood and a substance, which we will have soon, filtrate, exchange. As this is occurring, blood is filling up in the Bowman's capsule, and the pressure of this blood is raising. So we're going to then have our blood, if we're healthy, leave through the efferent arteriole and rejoin the rest of the filtering system in the rest of the body. So then we have this funky substance that becomes filtrate left, since the blood is gone. And the best way to hopefully picture this is if we go over here to the coffee pot. This is the coffee pot's filtering cup. And the filter here is similar to the glomerulus capillary here. This glomerulus, or the filter, the best way to picture it is if this coffee pot is the Bowman's capsule, as we have in the nephron. And what the glomerulus looks like is if we were to drop this filter into this coffee pot where they will be equally saturated. That's exactly what's going on in the beginning of the nephron. Once the blood has left, the filtrate remains, and it will enter the PCT, which is also known as the proximal convoluted tubule. Here is where one significant step occurs, which is often known as reabsorption. Reabsorption is important because the body wants what it wants. It wants its prime ions back, such as calcium, potassium, sodium, and it says, okay, in the filtrate, you've stolen some of these important ions, I want them back. So this is, in this part of the nephron, reabsorption takes place. Following along, we enter what is called the loop of Henle, and the filtrate becomes known as tubular filtrate. Just a fancy new name, as if this wasn't confusing enough already. As you can see, the lining here has gotten smaller, and this is for a purpose. The purpose of this is continued reabsorption, except what's different between this reabsorption and this reabsorption is that water ions are being reabsorbed in the loop of Henle because our body needs all of the excess water that it can get. As we carry on, water is being reabsorbed back into the body through the loop of Henle. Finally, we enter the DCT, which is known as the distal convoluted tubule, and an easy way to remember that it's more distant from the Bowman's capsule, and this one's more proximal to the Bowman's capsule in case you're confused about that naming. And this here is where the body secretes. So secretion takes place. The body secretes things that it doesn't want to carry any further. So for example, you're out raving all night. You do a lot of hard drugs. Molly, or everybody's favorite, cocaine. And you decide, your body decides that it's all through with that and needs to get rid of cocaine. So it's going to secrete cocaine into the filtrate, which then will be ready to enter the collecting duct, where this filtrate mixed with any excess waste turns into urea. And as you can imagine, the urea is dumped through the collecting duct, and becomes urine, which is what all of us are most familiar with. And through this simple process that happens all the time in various nephrons in the kidneys is how we filter our blood in order to make urine, which is what we want to dispose of. Thank you.